For 3.5, we're going to be talking about parallel lines and triangles. And our main focus today is going to be triangles. Now, there are two theorems we need to understand. The first one is called the triangle angle sum theorem. It states that if you add angle A and B and C, those together should equal 180 degrees. That's true for any triangle. That's something that has been known to you for a while, so it's just stating something you probably already know, that any triangle and its angles add up to 180 degrees. The second theorem is called the triangle exterior angle theorem. The measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. What they're saying is if I look at angle 1, that'll equal to the two angles that are on the inside on the opposite end of where that angle is, those remote ones. So it states that angle 1 will equal angle 2 plus angle 3. So we're going to use both these theorems to solve problems. So for the first problem, we're going to be using the triangle angle sum theorem. What are the values of x and y in the diagram at the right? So here we have one large triangle, ABC, and then we have a smaller triangle, ABD, and then another small triangle, BDC. And they want us to find the values of x and y. So the first thing is we want to solve for x, because we already know two angles. We know angle A, and we know this angle ABD. So these three angles with x should equal 180. So we're going to go ahead and state that 59 degrees, which is angle A, plus this angle ABD, which is the 43 degrees, this one right here, plus angle x, which is what we're trying to solve here, is going to equal to 180 degrees. So we're going to go ahead and add 59 plus 59 plus 43, which is going to give us 102, plus x is going to equal to 180 degrees. So we subtract 102 on both sides, and so x is going to give us a value of 78 degrees. So there's our first answer. So I'm going to go ahead and just put here 78 degrees for x. Now to solve angle y, one of the things we can do is solve for angle z. So to solve for angle z, we would have to use the angles A, B, and C and make those equal to 180. So I'll go ahead and say that 59 plus these two angles for B, which is 43 and 49, plus z is going to equal to 180 degrees. So these three angles will add up to 151 degrees plus z equals to 180. We want to subtract 151 on both sides. So z is going to equal to 29 degrees. So now that we have z, we can go ahead and put that right here. We can go ahead and use the smaller triangle BDC to solve for y. So I could say that angle D, which is y, plus the DBC angle, which is 49, plus 29, will equal to 180 degrees. We go ahead and add these together. So this would equal to 78, which equals to 1, and then all that equals to 180, subtract 78. And then we can solve that y is going to equal to 102 degrees. Alright, so this is one way you could do this, but there's other ways. I'm going to show you a faster way. So if I look at angles x and y, they're in a straight line. So let me go ahead and highlight that. So here's point D, and this angle x is 78 degrees, and here's our y. Those two are a linear pair, which means that these two angles add up to 180. So I just could have said, instead of going through all this, I could have said that 78 degrees plus y would equal to 180 degrees. So therefore, we subtract 78, and instead of going through these two triangles, we could have solved y, and that would have been 102. We still would have gotten the same result. For problem 2, we're going to be using the triangle exterior angle theorem. So what is the angle of 1? So we want to know this angle right here. So we know that angle 1 is the sum of its two remotes, which is 80 and 18. So angle 1 is going to equal to 80 plus 18. If we add those, we find angle 1. So angle 1 will equal 98 degrees. That's as simple as it gets. For part B, what is the measure of angle 2? So now we want to find one of the remotes. We have the exterior, which is 124, but we follow the same idea. 124 degrees, the exterior, equals its two remotes, 59 and angle 2. We solve for angle 2 by subtracting 59 on both sides. And that'll give us 65 degrees for angle 2. Now that you see a little bit of this triangle exterior theorem, I want to go back to the previous problem so you can see how you can use triangle exterior angle theorem on the previous problem we just did on problem 1. So here's another way you could solve angle y. Let me go ahead and clear all this out. So now that I have everything cleared out, notice on problem 1, I want to solve for y. There is a way to solve for y because y is the exterior of this triangle ABD. So I could use 43 and 49 as its remotes. So therefore, I could say that value of y, or the angle of y, is going to equal to its two remotes, which is going to be 43 and 59. Those are its remotes, the ones I highlighted in green. So that means if I add these together, I would solve for the angle of y or y. So y is going to equal the sum of those two, which is going to be 102 degrees. So that's another way you can make a shortcut. If you can see these remotes in any figure, then it's going to make your life easier because you're able to see and solve these a lot quicker than trying to go through triangle by triangle by triangle and trying to add up these angles. Anyways, this was another option of for you to solve for the angle of y using the two remote angles. These were the only two problems. You're going to just be working on triangles. If you have any questions, bring them up tomorrow. Okay, till then, bye.